All right.
Um,
Sir, please, I'm doing it.
okay, all right, okay then, very good. So we the discussion was that we needed to we gave you the things, that list of things. So this is going to be a hands-on kind of training program. I'm saying this because you will see some few things in the document. The first thing is that we are not going to introduce you to theories. We are not going to introduce you to hard theories that are required for machine learning model developments. We are not going to do that. We will normally treat this as a course in the school. If it's a course that you have registered for in the school that we are taking, that one will do that. So this one is more of a training hands-on development. What we will do, the closest we will do is for each topic that will require some technical background, we will have what we call foundational discussions. So we have like 20 minutes, 30 minutes foundation to give you how the architecture looks like, and then how the structure looks like, and the parameters you need to do. And then we start from that process on. So by the schedule that we have, today we are starting with introduction to machine learning. And under introduction to machine learning, there are some things that we will see. So I will quickly take you to those things. The first one is the objective of the training that we are trying to do, the outcome that we expect that when we finish, people should get, the basic requirements in terms of background, technical requirements for developing machine learning models for applications. Then we look at machine learning and its capabilities. We look at machine learning categories or machine learning algorithms. Then we look at machine learning methods, and then types of machine learning tasks that we perform in applications. And then lastly, we look at machine learning model development platforms and analytical tools that we'll be using to do model development. This conversation, as you see here, we have divided them into two parts. So one part is going to be 2 hours. Well, today, every session, maximum of 2 hours, minimum of 1.5 hours. So when we exhaust the minimum 1.5 hours, maximum 2 hours, then we cut off. And then the next meeting will be Friday, and then we finish. So based on the schedule that we have given to you, we see that each topic, we have indicated the hours that we think, estimated hours that we'll use to handle a topic. So introduction to machine learning, as we have here as this topic, is going to deal with 4 hours with the content that we see over here. So the first one that we'll look at is the objectives of the program. When we met with you as a kickoff meeting, we touch on this. So the main idea here is that you need, one, to formulate what we call a problem that is machine learning based. It is not every problem that we have to use machine learning AI to solve. It is not every problem that we have to use machine learning and AI to solve. Some of them we use rule-based. Rule-based means if this, then do this. That is not machine learning. So the one is to give you the knowledge so that when you have a problem, your research problem, whether you are undergrad student, master student, PhD student, or you are a faculty, research that you are, if you want to use machine learning, you should be able to analyze and see the need in learning. There is a topic after this introduction, the second topic is how to formulate machine learning problem. That will be taken by industry people. We have shared their work. So different people in different, how to formulate design to solve problems of it can to do anything, medical, any across board. Now, the second aspect also is to equip participants with knowledge and skill to build a career and growth. So if you want to build machine learning and AI, then this course is giving you the foundation that you need because it's hands-on. It gives you the foundation that you need to build that career. The third one is to provide you with hands-on skill to solve real-world problems. And this is particularly for final year students or students who are interested in developing their own research work using machine learning. And then the fourth one, provide a foundation to participants who want to acquire machine learning engineers certificates. Solution. So they have what we call machine learning certified engineers. And they shared some documents with me earlier on when I started the program with them. So some of the things that they try to do to help for people who go through the certification, I've introduced some of them into these documentations. Okay. So that is for the objective. Expected outcome. One, we expect that by the time we finish the training program, participants should be able to formulate machine learning solutions to real-world problems. So when you have a problem, you can formulate the solution. If it's a problem to deal with diagnosing health conditions for maybe developing a solution for healthcare application, by the time we finish, our expectation is that you should be able to formulate the solution, starting from what we call the planning, of first understanding the business, the nature of the business that you want to do, or the solution the problem that you want to solve. You have to understand. Then you plan. There's a cycle, development cycle. We'll walk you through that. And as you go along, we'll be teaching that as well with you. Then the second one is you examine requirements for real-world problems to ensure success of the application. People have developed solutions that has not been successful because it's not scalable enough. It's not addressing real-world solutions. So our expectation is that by the time we finish, you'll be able to have that kind of ability to do that. And you understand that the solution will be successful. The next session will dealt with from people from industry. We have all those things documented there. So they will take you through those segments on how to identify and establish success criteria for model development. Then the third one is to understand, by the time you finish, we expect that you would have understood machine learning architectures and then how to select a suitable architecture for a solution. There are different types of architectures. We'll be touching on some of them today. So by the time we finish, we expect that if you are developing a machine learning model for any application, and you have established that, yes, you can use machine learning to solve that application, then you must know what type of architecture, for example, to use for this solution. Then the fourth, which is one of the biggest issues, is what we call data preparation and processing. Data preparation and processing. So it's also a huge area that is required, and we'll walk you through again. So by the time we finish, we expect that you would also have good knowledge on how to do this. So people in industry, when they are working, they spend about 60% of the time to work on the data. 60% to work on the data. Because if the data is wrong, you get a bad solution. And also to understand and implement the model development, training, retraining, testing, deploying, scheduling, improving, monitoring, and maintaining the solutions. So this is the life cycle. The last one deals with the cycle of machine learning model. So when you have developed your program, you have designed your model solution, then you have trained it, and then you retrain it again, you test it. After testing, then you deploy it. How you deploy it, we'll talk about it. Then you now schedule the pipelines for getting data for continuous improvement, and you monitor against any failures here and there. Then you also do maintenance, typical of a software development process. So the first, having taken you through this, the next one is the background requirements if you want to develop a machine learning model. If you check on any of the public sites right now, check on Google, any of them, they will tell you there are certain minimum knowledge requirements or technical background requirements that you need if you want to develop, get into machine learning model development, because it contains a number of things, a mixture of things. Now, we are not going to go into the details of this, but what we believe is that every senior high school student has done something called algebra, simple algebra. So we are not, as I said, we are not going to the details of the theoretical framework, but we are giving you the basis. Why are we interested in algebra? Because machine learning model, developing a machine learning model is purely data. It's just purely data. A typical example is we want to sort out students in this university or students in engineering by departments. We want to develop a model that can help the school to sort out students by department. So when we say we want to sort out them by department, what do? Every student that we pick, we have to come up with a certain number of things that we, what you call attributes that we can use to describe each of these students. One of it, for example, we can say age of the student. Age is a number. Another one we can say is gender. Gender is not a number. It's a variable. It's a categorical something. So it's not a typical number that we can do multiply by something. So to develop machine learning model, we need to have data. And that data we perform, the data is arranged. In a few minutes, you will see some examples here. You will see that the data is arranged in a table form. Just like you have Excel, and then we have to do multiplication. So that is why we have to deal with what we call matrices, vectors, dot product, and a norm. The norm is finding the distance between X and Y, absolute value, distance. That's the norm. So you can, the norm, one of the things you can use, we call a distance measure. So you want to find X minus Y, absolute. So x squared minus y squared, square root of that. That is where we use the norm for. And there are a number of things that we use this in the machine learning model. So if you don't have deep knowledge, don't worry. We'll walk you through as we go along. We are not getting to the details of the theoretical framework on that. We'll walk you through the minimum. You know, you have a vector of 3 elements, and you are multiplying by something. Now, anybody can do that. So those are the things that we'll be working with you through. Then the next one is what we call calculus. Calculus, again, we use calculus also, some basic calculus. One of them is use derivatives, finding the dy ds, or if you call the rate of change. And then also we do what we call partial derivatives. We also use things like chain rule. We also use things like gradients. But again, these are things that we use them, but we are not going to walk you through the equations to confuse people. We are only mentioning because when we are going to train a model, we have to find out what is the best results that we need to have. So in finding out what we call the best results, we have something we call optimization. We have to minimize our losses. And this is where some of the way of learning, that is where we use this calculus. But we will only show you how it is done, but we are not going into the details of that. If it's a course, then we'll walk you through that. But this is a training program, so we only mention it for you. Another one is statistics. Statistics. So again, we need basic statistics like the mean, the variance, standard deviation, confidence interval, and on and on. These are things that help us to be able to interpret data. I'm sure some of you have heard of the term data analytics, or some call it data science. I mentioned that machine learning development is based on data. Without data, we can't do machine learning model. So the data that we have to do some kind of analysis on the data and try to prune the data to get the best quality data from what we have. And we use some of these statistical tools to be able to do that. So some of the libraries that we will be using, they contain all these things. So we'll only show you how we are going to use it. We'll only show you, so you don't have to worry about that. Then the other aspect, another thing also that we also need is probability theory. Some in developing models are based on probability. These things are also required, again, to be able to understand those things. But the libraries that we are going to use contain all these things. So as and when we use them, we'll let you know that we are using this to do this. So if you decide to do more career into that, then you can now get the opportunity to get a little bit of theory. Or if you are in computer engineering and you get to, I think, third year or so, fourth year, there's a course for machine learning. Then you take you to that. If you are doing graduate studies in computer engineering, there's a course for machine learning development. Then we'll go through those detailed theories. Okay. The next one is optimization. Again, for all the engineering students, you do something called, in third year, you do a course called numerical methods. And the numerical methods, one of the things that we deal with that is what we call some basic optimization. Again, I'm mentioning this because we will be using them again also in the development of models. That is, I mentioned that these are all things you don't need to have good knowledge in these things. As and when we go through, you pick the knowledge up. Okay. Then we have discrete mathematics. Some of the machine learning models, again, algorithms that we use also, some of them are also based on discrete mathematics, like logics, like combinatorics, like graphs. So those type of algorithms, they thrive on this. So again, when we come to those ones, we'll let you know. But I'm bringing this ahead so that you know that for you to work in machine learning model development, a number of things come in to do this. So this is the mathematical foundation that you need. Apart from the mathematical foundation, you also need programming. You also need programming. The programming platform allows you to be able to do the coding. And not, the coding here is you are not going to write logical functions. If this, no. They are what we call some simple syntaxes that we use, because these are functions. The libraries contain functions. Let's say, for example, if we want to find a histogram of engineering students in your basic high school, you have to have the data. So we have a library, and this library contains these functions. So we only call the function histogram function, and then we provide what we want it to do for us. So that is it. But in terms of programming languages, there are different programming languages that could be used. One, for example, is what we call C programming. Another one is what we call Java programming. Even R programming. R, normally the mathematics and statistics people, they use that a lot. But Python is one of the most versatile programming languages that has become a de facto for machine learning models. And we'll see that in a minute why it is so. So Python is, when we come to the session for the third session is Python programming. First is introduction to machine learning. Second is machine learning problem formulation. And the third is Python programming. So this is where, if you don't have any skill in programming, don't worry. We know there are some first-year students in the program. So don't worry too much. We will walk you through. That is the advantage that we give to students in this program. Nobody will walk you through basic programming, but we try to do this to bring people up to speed. So a session for programming, Python programming, where the key things that you need, will walk you through that. So Python is the most versatile programming languages that is used in machine learning model development. So our focus will be on Python. Now, there are also libraries, a number of libraries that allows us to be able to develop models. One of them is based on scientific libraries that has a whole lot of functions. Statistical tools, all the statistical tools that we talk about, there are libraries that allow us to do all those things. So when we get to that point, we will walk you through how to even install the Python, how to configure it, how to import the libraries, how to set up all those things. And you write your first hello Python programming to do some things. And then we also have what we call machine learning framework, development framework. So some of the development frameworks that we will use, they are the TensorFlow. So I support the TensorFlow because Google is sponsoring me for this, my project, my research. So TensorFlow is for them. So TensorFlow is what we use. And it's also what most people as well use. Let me put it that way. Okay. So apart from the programming, you will also need some knowledge as you go along called software engineering. There's also a segment that will also train you on, after you have developed your model, how you can put your model, integrate your model into a mobile application. So this is what we show students. You do a short as a training on that. It's a segment that will take 4 hours, 2 hours each. How you can do export your model that you have developed into a web application framework or a mobile application framework, and we'll show you all these things. So this is where the deployment process comes in, and that is where the software knowledge is in there. And then, of course, the APIs, how to develop API out of the conversation. We'll walk you through that as well. Then you also need database. So again, first year students and then non-computer engineering students are also, we have all the departments joining. So we'll not want to claim that you know, even if you know, we pretend that you know. So we walk people through the whole processes again. So let me say that for those of you who are already familiar with some of these things, you have to exercise patience for us because we are bringing everybody on board. Okay. Then the next one is data handling, which we'll also deal with at another session. Okay. Then model evaluation and then validation. And then we have machine learning operation. This is at the industry level. This is what goes on there. So after you have done all those things, you know how to deploy using, for example, AWS or maybe Microsoft Azure or web hostess. You have to now integrate your solution over there. And the reason why we use some of those solutions are that when we are dealing with machine learning models, it's because the level of complexity requires higher computational powers. So when you are using your general CPU laptops that you have, depending on how complex the solution is, you see that it may take a lot of time. For simple cases, simple models, that's what we'll be dealing with. You don't have a problem. But the industry people, the group that I work with at the industry level, sometimes we do work that you can take like weeks because you are dealing with millions of data. Millions, maybe 200 million data, 400 million data, and trying to do development using, or it takes you like weeks. So this is where the high-powered server systems comes in. And this is where, and they pay for those server spaces. But for your work, you are not going to do that. At least Google has, maybe I can share some things with you later on. Google normally give tokens for students who register for certain things that we do. And they give them tokens. So you are able to get some tokens to use some of their cloud services free of charge. Okay. And then this is the cloud infrastructure. So at least the Google Cloud, I can share some things with you, and then you can subscribe to that. So they will give you some tokens that you can use to develop models that you want to use freely. Of course, the token is not for huge things, but you can do for your research, basic research, final year, graduate level, and those sort of things. You can do that. Okay. So enough of this. So now let's look at now what we call machine learning. When we say machine learning, what is machine learning? Machine learning is basically a computational learning. A computational learning where we have algorithms. So listen, I'll put some things in under some underline certain keywords. They are computational. So computational means that we are not writing serious program to do this. They are only based on computations. And the computations, they use algorithms. And those algorithms are used to extract information from data. And the data, we call it raw data. So data of students, you can look at students, we are going to develop, let's say, a machine learning model that can predict the class of a student, whether the student is getting a first class, second class, third class, fourth class, whatever class. We can come up with a machine learning that can do that. So if you are going to use the machine learning to do that, we need to provide data. What data do we need to provide? Data on grades of students. So the model can then, the algorithm, let me use the word carefully. The algorithms that we are going to use can extract data to produce what we call a model. So when we say machine learning algorithm, and in that algorithm, we have passed data, raw data that we want to do into it, and it has given us a representative function, and that function we are calling it a model. So that is what machine learning is about. So what I've said is that essentially it learns from the data. What does it learn? It learns certain behavior. Some behavior may be familiar with, it may be obvious, but there may be some cases that they are not too obvious to us. Let's look at a case where we want to develop a machine learning model to predict the weather, whether it will rain or it will not rain. I made a statement, whether it will rain or it will not rain. So it means that I'm looking at two situations, raining or not raining. So I have to think of what algorithm I can use to help me do the raining or not raining. Now, the next step is I must have data. So what data do I need? So can somebody tell me, if I want to predict whether it will rain or it will not rain, what type of data I will need? Anybody? Anybody who wants to talk, you can talk.
Temperature.
So I will need temperature. Yes. So I will need temperature data. And then what else? Is temperature enough to let me know whether it will rain or it wouldn't rain?
You would need humidity.
I need what?
Please, you need the climatic pattern of the area.
Okay, so climatic pattern of the area. What else?
Relative humidity.
Very good. So I will need, so see that all that you are mentioning, these are, if that's why we said, if you want to develop a model for a particular case, you must have knowledge of that area. So if you don't have that knowledge and you want to develop something for predicting rains, it means that we must consult people who have knowledge on rain information. So it's okay if you want to predict what type of information do we need. It's okay, you need temperature, you need humidity, you need maybe certain patterns, on and on. So you have all these data. The person will give you, and so this information, they become the source of attributes or data points or sources you will need. So if you were to have a table, it means one table will have a header temperature, and then it lists out all the temperatures. Now, we also have, in terms of rain, see that we have seasons. There are seasons where the weather is dry, we don't have rains. There are seasons where we have rains. So we have what we call season. And you see that now people say that there is this issue of weather pattern changes. So sometimes we expect rain to fall, rain doesn't fall. But we can develop, I mean, that's those who deal with meteorological systems, they develop models to do these things, predictive models. So you can have this list of data. Now the question is, how much data do we need to be able to know whether it will rain or it wouldn't rain? So if you tell me that, oh, we need 1 week data, so we take Monday to Friday. Please, I hope you're understanding the conversation. If you have a question, please, you can pause, you can raise your hand and I'll call you. So we need, if you tell me we need weekly data from Monday to Friday, then I will ask you, is it every day? So the whole day, 24 hours, you need just 1 data point for the day, or how many data do you need? Do you need every minute data? Do you need every hour data? Do you need every second data? I don't know. But then what it means is that for us to know that range, we must have a long, I don't think we will need just 24-hour 1 data point. It means you need to have, if you are talking about temperature, the weather temperature is not just 1 minute. You see that we have temperature from morning, midnight, all the way up to the next midnight. We have humidity levels from midnight all the way up to the next midnight. So let's assume we are even using these 2 parameters, temperature and then humidity. Means that if we take from 12 midnight all the way to the next 12 midnight, we have different values. So if we decide that we are using every minute, it means that every 60 seconds, we are going to have a data, humidity, temperature. So if we take 1 day, how many data points can we have just for this? So you divide your number of 24 hours by 60 seconds, and you tell me the number of data points for only 1 day. So now you need for how many days? If you decide to do it only for January, you don't have, maybe the whole of January, there's no rain. So you don't expect the model to tell you that next January there will be rain. So it means you must have data that covers as much space as possible. So it can be 10, maybe 2-year, 3-year, 5-year, 10-year data. And each of them is this, if you are taking every minute, then you can see the number of data size, millions. And then this is the data. So it means that if you look at it with your naked eye, it will be difficult for you to tell whether it will rain or it won't rain. But in your model, your algorithm is going to now help you to navigate through all this data to know, oh, yesterday at 1 o'clock it rained, but 1:30 it didn't rain. So to learn all the patterns that are not obvious to you in that data. And then after learning all these things, the pattern, the relationship, it will give you something called, this is what I have, a function. And that function is what we call your model. So if you now want to predict, then you can now pass a temperature information and humidity information and tell me whether it will rain or it won't rain. And that's where it is coming in. So that is what we talk about as far as machine learning is concerned. And then I mentioned machine learning as a computational learning. I mentioned model, and I mentioned algorithm. So algorithm at the tail end, I said algorithm is a mathematical program or logical program that turns the raw data into a model. So it's a mathematical framework or logical framework. So remember I mentioned some algorithms are based on statistics or probabilities. So if a statistically based or driven algorithm, it may have that statistical functions in it. So you are only calling that function and then pass your data into it. If it is a logical sequence that based on the hierarchy of a system, then that also does that for you on that. So that is about that for the machine learning. Now the next one is, what is the difference between the traditional learning or artificial intelligence learning and the machine learning? They are 2 separate components. Now, when we come to traditional learning, what traditional learning does is Traditional learning uses what we call structured data. Let me see. I think I have something. I will share that one with you. Okay. So the traditional learning, what it does is, let's say it first has what we call structured data. So this is a structured data. Traditional learning has what we call structured data. And it also has what we call the rules that we are going to use to act on that data. So I have 2 data points. I want to do something. I've selected the first number 2 or 20. Then I selected the second number. The second number is 3. So I have 2 values, 2 and 3. What rule do I want to apply on that, the 2 data points that I have? So I can apply multiplication, I can apply addition, I can apply division, I can apply logarithm, I can apply anything. So what I want is, that rule, I'm saying that when I provide, I have 2 numbers, and I said the 2 numbers, the rule I'm now saying is that I say what? Add these 2 numbers. So the rule is adding 2 numbers. So the 2 numbers, I'm going to add 2 and 3. When I add 2 and 3, what would it give me? The 2 and 3 will give me an output called 5. So what I'm going to do, for traditional, I'm going to write a program. That program is going to take input data. So it asked me submit an input data. So I submitted an input data. It asked me submit the other data. I submit the second data. And the rule is that add these 2 numbers and then give me an output. So this is what the traditional learning system will do. Traditional learning system. So it is based on, it has a data, structured data, and it's also based on rule. And the rule will act on that data to give you your output. That is what traditional learning will do. Now, machine learning. Now, if you look at the 2, you see that the traditional, first, I have the data, and then I have the rule that I want to use. The data, and then the rule that I want to use for the traditional learning system. So I can write a program that should be able to do something for me. And I say, I'm using intelligence to do this. So I provide my rule. This is what I want. But when you provide the algorithm, not the rule, you provide the data and you provide the algorithm, not the rule. So the data and the algorithm comes together to establish the rule for you. And that rule is what we will now get our model. So when it comes to algorithm, work together to give you what you call your rule. So it learns through the data, the relationship that is existing within that data. It can tell you that this number that you have, it is this. So in the machine learning process, let me just mention one other term that is important. One of the algorithms that we use, we call a super learning. So we'll talk about supervised learning here means that when I provide these 2 data points, 2 and 3, I must also provide what I'm expecting out of that. I must provide what I'm expecting out of that. So I provide 2 and 3. And I said, I'm expecting an output of 5. Output of 5, there can be so many things that would lead to output of 5. So there are a number of rules that I can formulate that will give me output of 5 when 2 and 3 are combined. So this is what the algorithm I provided my 2 numbers. I apply my 2 numbers to the algorithm. Formulate the rule for and out of that model, then I can now apply a new set of data to it and to now give me what I'm expecting. Okay, so we look at provide what is expected. Temperature, humidity, what is expected. Temperature, what is, so I provide for each one of the data point, each of the data. And then what I will do is this input, these 2 data points, I will apply that as what I call my input to the algorithm. I will apply my input to the algorithm. And then I'll apply to you. I want between these 2, but the relationship for the 2 and 3, I'm expecting an output of 5. Between 4 and 5, I'm expecting an output of 9. 1 and 0, I'm expecting 1. So I'll tell the algorithm this is what my expected output should be. So when you are learning it, let this be at the back of your mind that I'm expecting an output of 5, these values for each pair that I have. So it will go through that algorithm, and that algorithm will now, I provide this to that algorithm, and that algorithm will now learn through that process. And then it will now tell me that, okay, once you provide this through me, and then you say that, okay, this is, I don't want to jump the gun, but I will tell you what it will be. Let's say, for example, that when I provided 2 and 3 into the algorithm, it gave me an output of 4. What do you think will happen? Any suggestion? What do you think will happen? I provided these 2, temperature 2 degrees, humidity 3. And then I provided to the algorithm. And then he said, oh, when you see this and that, I've looked at the relationship between the 2 of them. And I think the output should be 4. Do you think it's correct?
No.
Why?
Comparing the X and the Y's, so when you provide an input of 2 and 3, we are getting 5.
Right. So this is what we call the actual data, the reality. So let's say that, okay, so that is, so the actual is, the algorithm is trying to learn a relationship and tell me what it thinks should be the answer. But in reality, the actual is supposed to be 5. So this is where we say that this is serving as what you call a guide to help the algorithm to learn the data better. Please, have you understood that? So I provided these two inputs, and then I tell the algorithm that now, when you see 2 and 3, and I've put it, and you give me an answer of 4, it's wrong because it's supposed to be 5. So what should the algorithm do? It will see that, okay, the output 4 and the 5, there's an error margin. So 5 minus 4 is equal to what? 1. So there's an error of 1. So it will now use that error to go back and correct itself. That is where I mentioned in the beginning, I said optimization. So it performs what we call some optimization process to minimize the error that is coming out of the learning process so that it will go through as many cycles. And when we start a program, you yourself, you will see that because you are going to do it. You go through a number of cycles, and out of those cycles, it will come back and tell you that, okay, this is the best I can do. So maybe it is 4.99. So 4.99, then we ask ourselves, at what point do we say it's enough is enough? 4.99 and 4.9999 is 4.9, error of 0.001%. We can ignore it and we call it 5. So once your model is able to give you very good responses from what we are expecting, then we can say that the model has learned very well. So again, in the model development process, we also have to establish what metrics we are going to use to evaluate the performance as to whether it's learning well or it's not learning well. So we also have something we'll go through in later time, what we call performance. All of us, at least every one of us we are students, unless we are lecturers, but there are some lecturers on the platform. So if you are a student, at the end of the semester, you do exams, and then you'll be graded. When you are graded, then you declare your performance. Now, so if based on your performance, if your performance is good enough, your question is, what will inform your decision that you are performing very well? Can somebody tell me how you know that you are performing very well?
Your GPA.
Very good, your GPA. So it means that your GPA becomes a markup that you are going to use. So when you get your GPA of 3 point something, then you can say, oh, you are doing very well. So we must have a metric, a performance measure that we are going to use to evaluate your performance in the courses that you have taken for the semester and see whether you are doing well or you are not doing well. So this is what the model is supposed to do. So once we go through the process, then it will tell you that after going to an summation rule, addition rule. So then it means that I'm done. So when I get this in the context of your examination, it's GPA rule. So if the CGPA rule, then that CGPA rule is now what is going to be used as what we call your model. So all the things that have been learned has been encapsulated into a function called into that, it will now tell you have done very well or you haven't done very well. That is where we also want to do what we call some prediction. Again, we want to predict your expenditure as a student in school, your weekly expenditure. So in determining your weekly expenditure, you have to itemize things that how much you spend a day, the things that you buy, you create a table on all of them. And then based on you provide, okay, when it can predict that this is what I'm spending. So these are all variants of the things that we want to look at. Again, this is also another set of data that we have, ages and then weight of students, and we can use that to determine a certain number of activities. So we can again check and find out. In this particular case, you see that we are plotting age versus weight. So somebody can say, I want to establish your BMI or any whatever you want to do. We can come up with it. We can look at it from that point of view. So when you sketch this data in your basic, I don't know whether you did that in your senior high school, but we have something called linear graph. And the linear graph, you need to have a number of points. And that number of points, you look at the line of Bear's feet. The line of Bear's feet. When you get, so you have what we call scattered, we call it scatter plot. You draw all the points. And then you look at what is the Bear's line of feet. When you draw your Bear's line of feet, some of the points may be on the line of feet. Some may be getting a little, some may be very close. So you see that when you find a deviation, you can find out the deviation from the Bear's line. And then out of that Bear's line, you'll find out how much error you are losing. And out of that circumstance, you'll now find out what is the linear graph, that a linear equation that I can create out of this line graph. You need 2 points. If the line is okay for you and the error margin is acceptable, then you need 2 points, and that 2 points will help you to have what you call your line. With that line, you can now extrapolate the line very far because it's straight line. So you cannot determine anybody, when you get the new person's age, you can determine where the person's height will be on that graph. And that is what we call linear. So they will look at it also again in what we call something called linear regression. It's one of the models that we use to predict what we call continuous data. So we call it regression. Again, another example is you can predict your performance in your GPA performance. You can predict. If you know, in that particular case, if you did 6 courses, it means that you have S1, S2, S3, up to S5. So you draw the lines. So it means that you are not going to have, this is a 2-dimensional. You're going to have a multi-dimensional data. So as part of these things, we also walk you through all those things again. If somebody wants to perform, again, something like prices of goods, or the last time we did this, some students work on things like forex exchange rate prediction. Some also looked at GDP prediction. I mean, you can do many things with these kinds of models. Okay, so for what I've just explained, see that you can now draw your line of Bear's feet, and that line of Bear's feet will give you your, and you can get the equation y is equal to ms plus c. So now, if you know your variable as age is what you are predicting, if you know your m, that's your slope, and you know your weight, you can tell what the age will be straight away from that. So this is when we are dealing with something that gives us a model. In the case of prediction, or where it is regression models, we call them regression models. So regression models, linear regression model. So for linear regression model, we have this, and this then becomes our rule. Y is equal to, based on this line, we have calculated what the slope is and what the intercept value is. And then once you put in your X, which is your weight, it just gives you. So when we have our linear model, a linear algorithm, regression algorithm, and we try and fit the data into it, it will produce the rule for us. And this is the rule that is going to give us as an output. And this is what then, if you are developing something for, let's say for a application, a mobile application, then you now export this rule onto that mobile platform so that anybody who wants to predict, they will say, okay, now enter your weight. When you enter the weight, they predict the results for you. Enter the weight, they predict the results for you. That is the age. So this is what, so you see that this is not going to rely on writing a litany of programs with logic and no. It's just the type of algorithm you are going to use. And then you pass your data through it. But again, the process for doing this is a bit laborious because the data that we have, let's say, for example, this data that we have, if I remove, you have the age, 2, 4, 5, 6, 7, 8, 9. Let's say the 9, it is empty. And then the 20, it is -2. Can we say that any human being has an age of empty? I'm asking. Can any human being has an age of empty?
No.
If it's an age of empty, what do we how would we interpret it?
No value. If
that person has not even been conceived. The moment conception takes place, the fetus, we have weeks, it grows. So if we have data, and then 20 there, assuming that 20 is -2, and then you say somebody has an age of -2, it's weird. So see that if somebody gives you a data like this, then look at the 7, I'm deleting the 7 to make it empty. Empty is null set, null value. And then the 20, I'm putting -2 there. And I say, oh, I've given to what name? Let me see if I can get a name on the somebody's name. Let me see a name that I would like.
Thelma.
Is Thelma on the line? Is Thelma on the line?
Yes, please.
Okay, somebody has mentioned your name. So if I give you this data as a machine learning developer or engineer, and then the data that we have, I said we want to predict age of people. So you are developing a model that will allow people to do this. And the data that I presented to you, where the 7 is, you see empty. And then where the 20 is, you see -2. What will you do?
So please, you said where the 20 is -2, right?
Where the 20 is, I'll put -2 there. And then where the 7 is, the age, -2, I'll put empty there. So I've given this data to you, and I said, can you develop a machine learning model that we can use to predict the age of students?
So I think since we already have the equation, and then we know
you don't have the equation. We now have the data, and we are now going to use the data to develop the model, and the model is the equation. But the data that you have, where the 7 is null, is empty. And then where the 20 is -2.
So usually when you're giving data, you check the trends, right? So in this case, given you have the ages and you have the weights. So when you map it out, you're able to get an equation out of the data given.
Okay, so that is Thelma. So can somebody help her out? Or any other suggestion?
Well, you can
replace those numbers by averaging it by, with the average of the number numbers near it.
No. Is it Jeffrey?
No, David.
David. So why do we
Yeah.
have to replace it?
Because these numbers are invalid and can confuse the
Very
model
good.
you use.
I want to establish something. So you see that when you have the data, if you look at the data and you just put the data in there, what it means is that your model will know that if it's going to learn, it will know that people have ages of -2. And it will also know that there are some people who don't, there are some ageless people with age of null, non-existent. So when, assuming it learns and then it factors all that into the learning process, and then you give somebody's weight of 45 kilograms, and it tells you that the person's age is -5, will you take it?
No.
No, because nobody has any age of -5. So when you see that data, immediately what you say is that this data, there's some error in it, because there's no way a human being will have an age of -2 or -5. And there's no way a human being will have an age of no age. It means that the person has, so this is where your data, because if you don't do anything about it and you put it in a model, the equation that you have, taking all that into consideration to give you this. So there's a likelihood that you will pass somebody's age of 25. And so this age of 25, maybe a level 200 student, I'm expecting that, or even level 400 or 500 student, I'm expecting this age to be maybe 22. And it tells you the age is -6. You say, come on, how come level 200 say -6? But that is what business decision. Even if you want to kick people out, you want to use that. You see that you will create unnecessary problems. So that is why it's very, very important when we are dealing with model development. Because in that case, we have to go through the data and then find out, for all you know, we can say that how were these data captured? You said, okay, somebody at the research in the office, let the administrator, will be recording the ages of student, wrote -2. So that is why it is there. So you see that as an anomaly. It's not normal. So when we come to the data side, we also show you, walk through the processes as to how we treat data. We will spend a lot of time on the data preparation. You are going to do it. We'll walk you through it. You will do it yourself. Okay. So that is what the solution is. So once we are done with that, it then helps us to establish what the model will be. So after we've gotten the model, now the rule that it takes here, that is what we call now our model. And that is what, whether we are dealing with a web app or we are dealing with a mobile app or you are putting it on IoT device, that one, so we walk you through all those things, whether if you are using it as IoT device or anything that you want, either web application or mobile application or IoT. So we'll walk you through all these 3 applications, okay, for deployment of this model. Now, the question is, are there any differences between, we have heard of the term artificial intelligence, we have heard of the term machine learning. Are they one and the same thing, or there are differences? Anybody who has some knowledge or has some brief idea can share with us what his or her knowledge is about it, the difference. Anybody?
Okay.
Yeah, please go ahead.
Hello.
Yes, please go ahead, talk.
Okay,
We are
I
listening
said
to
I
you.
know that machine learning is a subset of AI, artificial intelligence. That's
Okay. Yeah. Anybody else? Anybody else? Okay. So when we talk about, yes, please go ahead.
Okay, so what I know is that AI is a blanket term used to describe machines simulating human intelligence. Machine learning is a specialized subset of AI that uses data to improve its performance and prediction.
Yeah. So both of you are correct. So machine learning is a bigger, AI is a bigger umbrella. The bigger umbrella is to make machines behave like the human brain. It's very smart. The idea is machines to behave like the human brain. That's the artificial intelligence, to make machines behave like the human brain. And how to make it behave like the human brain is what the machine learning does. So AI looking at how to make things very intelligent, bigger things, how the human, everything works, very intelligent, smart, and that is the AI. And then the machine learning is the engine that makes it happen. So machine learning enables the artificial intelligence to achieve its goal. So they are closely related and connected. You cannot separate artificial intelligence from machine learning. So we talk about AI. What is driving that AI? That AI is the machine learning. That is, so summarily, I'll put it as that. Okay. Now, why do we have to learn machine learning? There are a number of obvious reasons why we have to learn machine learning. One of the reasons is that it is the driving force behind many of the innovations and technologies that we are seeing now. In the past, it was basic knowledge, or if you call it programming knowledge. But now, with machine learning, it has turned around so many things. And those of you who are more interested in technology news, you can see that right now, let's say for a typical, we have even now your ChatGPT. When we give homework, for example, in school, in class, some of you, all you do is you put the homework into the ChatGPT and then you say, oh, we are doing something called prompt engineering. So you are applying some kind of prompt here means applying keywords that will direct the ChatGPT to what you want to see. And then what it will do, it will tell you the solution of whatever. Without machine learning, these things would not have been possible. So we can see that machine learning, for that matter, that is the engine that is driving artificial intelligence, is making things more exciting and more innovative and more smart, that it has made industrial demand for machine learning engineers very high. So you see that almost every time when there is an advert, they will say, okay, maybe some blah, 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 they say, oh, maybe some good knowledge or knowledge in machine learning, because now everybody is investing in machine learning. Recently, the Ghana government, they said they published a book on Ghana's AI documents. I'm praying that the government will put money into that so that some of you can write for proposals and then get money to develop solutions. It has become a big thing now. If you look at China is pumping billions of dollars into AI. US is pumping billions. So almost every country is pumping money into it. Why are they putting into it? Because it has become now a household name that everybody is using it to make things smart and better. Whether you are dealing with industry, whether you are dealing with healthcare, whether you are dealing with even education, finance, on and on and on. Working with some industry as part of some collaboration that we are doing, trying to solve some big problems for financial institutions. Looking at huge AI development for machine learning for fraud. So you see that there are a number of things that people can easily do once you have the knowledge. So the key point is that it is driving a lot of changes in what we are doing now. And the department, for example, we have a partnership with Telecel. Recently, they gave me they sent something to me for us to consider for them, about almost 17 research projects that they wanted us to partner with them to solve, but at a graduate level, master's level. So a number of master's students interested there. Solutions. So you can see the direction where people are heading towards. Now, another reason also is that machine learning can produce accurate results and analysis by developing efficient and fast algorithm that otherwise will take a lot of time. If we have something called data mining, if university wants to find out, let's look at it. If university wants to find out all the number of students in the university, they want to find out the best student with the overall best GPA. How would they go around it? Somebody will have to write a script to go through all these things, lines of code to be. We can develop a machine learning model that we can mine, we call it data mining. It can mine the data to tell you that this is the best student in the university. I mean, so AI we can do so many things with the machine learning. And because it can make things very fast, more accurate than human, one of the financial institutions were telling us, for example, that when people apply for loans, for example, sometimes you want a smart solution where there will not be too much interference. So the person applies, fills the form, and then it goes through the pipeline, the processes all through, and determine whether this person can pay the loan or not pay the loan. So if you want something that can do a job that, let's say you hire a person that will be handling maybe 10 or so, the person can do about, let's say, 10 or 20 customers a day. When you have machine learning, all you do is 100 or 200 people can apply online. And within seconds, it will just tell them straight away. So you can see that when people say that people are going to lose their jobs, we can see where it is heading towards. Because then hiring one person, if you want good productivity, get people to be doing this loan application for you. All we do is just invest in the machine learning algorithm. Then it will give you as many as possible. So the 2 or 3 people you are going to hire, you don't hire them. You hire one person who understands machine learning and can help interpret the data that is coming out of it. That's what you will do. So we can see that there is some good demand as to the focus, but still the machine learning will come, AI machine learning will come in, but almost every time is the application that is what drives the need. It's the application that is what drives the need. So different applications will come in. Some of you will develop applications that will attract industry usage, and then it changes the way people do things. Now, the last but not the least is that machine learning is the forefront of, and every industry is now seeking for its implementation in diverse application domains. Through that, what it has opened doors for broad scope of opportunities for people who have good knowledge in machine learning developments. So we normally combine AI, ML with analytics, because they need to analyze the data and then make interpretations of the data when the model has been developed. And it helps the future-proofing career maintenance for competitive. So if jobs are going now, what happens is that right now the global world is now changing. I'm sure some of you have heard about something called cryptocurrency. Now, again, people are developing solutions along these lines. People are developing solutions for even that is going to enhance more of what we call this online transactions that we do. So it's a matter of time that all these things will be changing based on the need and what people come out with. These are some of the benefits. I think based on what I've explained, you can infer from the fact that there are a number of benefits that we can derive from that. So as I bring the first segment, there are a few things I'll touch on briefly, then we'll see one more demonstration. So to develop machine learning model for any application, we need understanding of the business solution that we want to develop. We need understanding of the data. We need understanding of the data collection techniques, how data is collected. We need data analytics. Analytics is where I mentioned the statistics. That's where we do the analytics from. And then we also need model building, how we develop the model, how we train the model, how we test the model, and then how we evaluate the model. And after the evaluation, if the model is good enough, of course, we measure the accuracy, and if it's good enough, then we deploy the model. And we have to look at the deployment platform. Where do we deploy it? And then after the deployment, we also keep monitoring it. We can't do things, we can't use the same thing forever and ever, because let me give you one example again. You see that a number of people are, one thing that has become clear, I'm sure, again, Ghana Cyber Authority, one of my master's students, we are working on a project on that with them, on cybercrime kind of thing, detection. So one of the things that we see is that the ways human beings commit crime, they always come with different modus operandi. You have a particular trend that this is how people do things, and tomorrow people change the way they do things. What it means is that your model would have known how people do things in a certain way, but the new direction, they wouldn't know that. And then we do maintenance. We do monitor and then maintenance. Let me just add one quick one on the maintenance. Many of you who are familiar with this, what you call DSTV. And of course, I can even move from DSTV to even your laptops that you use. See, sometimes they have what you call patches. Every now and then they bring in a patch. They will say, oh, we are updating. So the same way, why would they want to do patches? Because they have done studies and they've seen that over time, there's a new signature. People are introducing a new approach to infiltrating into the system, and they have detected that. So what they will do is they will train a new model, and then they will update an existing one. That is why they do patches. Otherwise, if you don't do maintenance, you are doomed. So in trying to do the development, we have this kind of cycle that we plan. We have to plan the project. So at the industry level, even if you are doing it for research, whatever, you start with the planning process. This segment that I have here, we will talk about that in the next session. So you plan approach, then you do data acquisition and preparation. You plan. Planning involves understanding the business, what you want to do, the type of solution you want to have, the success criteria, failure criteria, whether you can even do it using machine learning. What type of machine learning can be done? All these things are based on the data that you have, even what type of data I need to do. So we go through the planning process, the data preparation process, and then the model engineering process, model evaluation process, model deployment process, model operation process, and then model monitoring and evaluation process. So after we have deployed it, so these things that you see here, this pipeline that you see here, we are going to have session under each of them. And then that is the process. So that by the time we finish, we expect that you would have had some good grounding. So the machine learning flow process, we need to have what we call, apart from the basic segment, we need to have what we call the data. As I said, see, data is the backbone of the machine learning model. Data is the backbone. Without the data, we can't do anything. So we need to, at the planning stage, that is where we identify the type of data we need and all those things. And then we now go for those type of data we need. If we need a data that we don't have that data, then we have to figure out how we can generate, how we can acquire that data. When we come to the model, the segment for data processing and those things, we'll talk extensively about that. We have something we call synthetic data generation. So some of the students that we have worked and published learning solutions in different applications, some of the data. So we meet, especially in the healthcare area. So we meet with the consultants in Korle Bu. We sit down, they give us the knowledge, and out of the knowledge, we generate data from the knowledge they give us. And then we use that data. That data is called synthetic data. But that data is too pure. So if it's too pure, we introduce what we call nuances to make it look more like a real rough data. Noisy. We introduce nuances, we introduce noise into the data to make it look more realistic. And then, even if you take attendance in class, there are some students who don't come to lectures, but people will still force and write attendance for them. So when you are dealing with attendance records for students, if you don't have data, we figure out how we can get the data. So we generate data, and then we can now introduce that nuances into it to look like, okay, this is a real data. So we say, okay, there are some cases where out of the lot, about 1% or 0.5% will not come to lectures. So we would give them some, people will force signatures for them, something like that. So we identify the data, and that data we identify, we call it, that is a raw data. And that raw data, that is what we call experience. And it has different names. One name is the raw data, another name is the experience, another way is also sample. So they mean the same thing. So when we have the data, we now move to the next step to prepare that data. So in preparing the data, like the example that I gave, the table, null data, and then -2 data, we see that that data is not correct. So we do what we call, we clean the data to make the data a good quality data. And this is where we use the analytics. So when we come to the Python discussion, installation, and the libraries, and we start, we'll show you how you do all these things. We'll use real data to do these things. And then we'll introduce noise in that data. And then we'll go through with you to see how we can clean data to establish that the data that we have is a clean data. And there are also processes. One of you said, for example, you can use the average. There are different techniques. So we'll also introduce you to, we'll also show you those techniques that can be used to miss, if it's a null, there's a data that is missing. So how do we fix that missing data? So show you some of the techniques that are industry standard techniques available for fixing missing data. And then let's look at the data I also mentioned, -2. -2 also is erroneous data. So how to fix that one? And then we can see somebody's age, 500. There's no way somebody's age will be 500. So when you have somebody say, no, this one is what? It's an outlier. Then we have to take it out. So we go through techniques that we use to fix all these in an attempt to make the data look clean as far as possible. Once we have established a clean data, then we will now decompose the data into what we call 3 segments. One segment is, we are going to use one segment for training the data, for training the model. We use another data to test the model, another data to validate the model. So when we come to that segment, we'll discuss it. But this is the machine learning model, the workflow diagram. That is the first one that I shared, the one before is the development. That includes everything. But this one is narrowed down to the model. If you want to develop the model component, these are the things that we go through. Okay. So after we have prepared the data, now we now choose the type of machine learning algorithm that we want to use to build the model. And the choice of the algorithm will also walk you through how to select the algorithm. But the choice is based on the data that you have. The data that we dealt with, where we have X1, S2, and then the Y. If we have the data that has only X1 and S2, but there's no Y, it means that the data that we have, there's no guiding principles to tell the model that you are correct or you are wrong, not correct. So that type of algorithm, we refer to that as unsupervised. There's no supervision. So based on the data that we have, we can tell whether we are going to develop something that is based on supervision or something that is not based on supervision. So we have what we call supervised learning algorithm or unsupervised learning algorithm. Under the supervised learning algorithm, there are different things we can do. If we want to classify students into groups, it's different from if you want to see the GPA of a student. If you want to see the GPA of a student, you want to see an actual mark. Different from if you want to put a student into level 200, level 500. Yeah. So you see that there are different things. So if you want to do different things, putting students into groups, we call them, we are classifying them. We are not interested in the actual value. We are interested in this student, it belongs to level 200, level 500, level 800, things like that. So there are a series of algorithms under supervised learning that we can use to do these things. And then we can also have unsupervised. So if it's unsupervised, it means that the system doesn't know whether it is, if to give it an output of 4, it doesn't know whether it is error or no, because there's nobody guiding it. So we refer to that as unsupervised learning. So the unsupervised learning, then we have to establish what criteria do we use to know if it is going wrong or not going wrong. So there's also a number of algorithms that we have under that, industry standard algorithms that we can use to develop our model. So after the model has been developed, then there's also something called, another type called reinforcement. There's also something called so where we have half supervised, half unsupervised data mixed together, we can also use that. So depending on the nature of your data, then that will help you to decide which type of algorithm you want to use to build your model. After the model has been built, then we train the model building, we have something called parameters. So those parameters, we are going to, after we have trained the model, then we want to find out whether the model training is good enough. For example, the regression that we saw, where we saw the line of the y is equal to ms plus c, where some values have been given to us. We want to find out this model that we have, is it a good model? Has it fitted the data very well? How accurate is it? So we have to now evaluate the performance of the training that we have gotten. And then, you mentioned, I said we divide the data into three. So one of the data set, we use it to train the model. We need to generate the model, right? Then the second one, but we test and see the performance. Then the second one, we use it to test the model. So then we will now compare the performance of the testing with the performance of the training. If the deviation, if the model training is good, then the testing performance should also be good. If the performance is not good, there's a big difference. It means that your model has learned noise. So we have to come back and do what we call parameter tuning. So what we say is that the model is either overfitting the data or parameter tuning. We do tuning we tune the model again so that we can get a revision. And then after that, they will now go back and then validate it. And if it's okay for us, then we can say that we have a good model. So developing model takes a lot of time. Developing a machine learning model takes a lot of time. So if it's going to take a lot of time, see that the data is the key thing that is going to drive, because with the information of the data, you can get the rest. So in the form of a flow chart, this is how our model looks like. If we have, so at the industry level, when we have done all those things, we have what we developed, we call a pipeline to automate the process. That's what is done. We develop a solution for, let's say, Kolebu. They will not give you all their data. They will give you a partial data. So when you have done the data, you have developed whatever you want to do, then you give the platform to them. Then they can load that data into a S3 bucket. Okay, so they load the data into a bin. And then your model pipeline, the processes that you have iterated, it will now go through all those processes, automated. So we have the data, and the data that we have will now go through the next process of the data by going through what we call the pre-process. That is where we do the cleaning and all those fine-tuning, or just prepare the data, let me put it that way, to get a good quality data. After we have gotten the good quality data, then the next thing that we do is that now with the good quality data now, we now split the data into training data set and then test and validation data set. Training data set and then test and validation data set. So the training data set, the data is what we are now going to put, the training data is what we are now going to apply into our algorithm that we have selected. And that algorithm will now go through the cycle to give us what we call a model. And then, of course, as part of those things, we also we evaluate the model performance, and then the training model performance and the testing model performance, everything. Then once we are done with it, then we'll now save the model. Well, it means that we are happy with the model development. So we save the model, and then now we'll now deploy the model into whichever environment we want to deploy, whether you want to deploy it as a mobile application, or you want to deploy it as a web application, or you want to deploy it on an IoT device, maybe a Raspberry Pi or something, or maybe Jetson Nano or NVIDIA, any of those boards, if you want to, so that is where then we come in there. Of course, because depending on the deployment platform, because this needs a lot of memory. So depending on the deployment platform, if you are using an IoT solution, means that you may not have the luxury of high memory capacity. So we have to go through something called light, so that we scale it down to a very light version that can be deployed on it. Let's take a typical example that you are developing something for, let's say, the electricity industry or Ghana Water, either Ghana ECG or Ghana Water, on their meter. The meter that they have, the memory on the meter is not as big as the memory on your mobile, on your laptop. So how can we deploy a machine learning model on the memory on such IoT-based solution? This is where we have to now use IoT Lite, a light version of, so the deployment platform, when we are using the TensorFlow, it will show you how to do it. If you want to use a light version for IoT, there's a navigation that will take you through to do. If you go to use it, there's also a navigation that will take you through to do it. So that is about that for the operation on this. So now the next segment that we have here is, I want to now walk you through some application briefly. Then after that, we will do some quick exercise. I will introduce you to some application that you can, at your spare time, you can play around with. Okay, so we have application. So at least by now, many of you are familiar with, at least you have heard about what AI and AI ML can do. So we are not going to preach to you converted, but what you know is that it is not every solution that we want to apply machine learning, because the reason being that some of the solutions, machine learning will be too cost effective, too expensive to deploy that on it. So some of them can be simple rules. But if you want to use, otherwise, anything that you can think of, you can think about, machine learning can be used to solve that problem, provided there's a high value for it. So web searches, we can use. Now, I know biomedical, for example, Dr. Kofi, Sam Kofi, he does something on AI for machine learning for computational biology. So they do something like for the DNA, things like that. Okay. At least I have a preview. Some of his former students, they took these machine learning courses that we are running 2 years ago, 3 years ago. Different students, they took it, and then it helped them in the work that they were doing. They did. Okay. Then the financial sector, e-commerce, healthcare. I do a bit more of work in the healthcare now with the dean. Okay. Then we have robotics, Now I'm also doing something now with the robotics. We have autonomous service, we have manufacturing, and I'm also doing something also on for the what do you call I did something with UGCS for a university network. For early stages, some of you were doing P2P. So we developed a solution. One of the managers there it was my master's student. We developed a solution for deployment on that for P2P. But now they have even discarded it now. So, but that was what we did, and they were using it. We have a customer relationship. I mean, all these things you can think of and more. I can't say that, then more of them. They are all applications that we can use for machine learning. So, let me see how much time I have now. Let me quickly pause here, and then the next topic that we are going to work on is the machine learning algorithms. So I would pause here and then quickly introduce you to that one. Is more fun. We'll introduce you to the fun, and then after that, if you have questions, if not, then we'll close. And then Friday, we'll conclude with the rest of the segment we have here, the different types of algorithms that we use. And then we'll now link it up now to the neural networks, where the human brain, how it is mimicked, and we'll show you some few things, how it is done, because we are going to use that for the subsequent, when we start with the model development, that's what we are going to use. Okay. So let me pause for if question whilst I prepare and take you to the next level of the fun. So those of you who have your laptops on, I'm going to share something, and you can look at it at your, you can open your web browser and look for it. So the floor is open for questions. If there are questions. Any question? Do you have any question, please? If there are no questions, then I presume that maybe it didn't go well.
Hello, sir.
Yes, please, I'm listening.
Yes, so concerning the deployment that you're talking about, you mentioned either a light version or the heavy use. So I wanted to ask, what major difference would be for a light version, that the one that TensorFlow offers you, and then the heavy version? So does it compromise on accuracy, or what was the major difference?
Okay, so let's look at it this way, that you want to prepare a machine learning. Let's use the weather as the rain, the weather it will rain discussion. Let's look at it from that angle. So now you want to develop this solution. And now you look at the data that you have. The data that you have, millions of data. Now, if you were preparing this, how long would it take you to prepare the solution? You see that the data you need is a million set of millions of data to do the preparation. So in terms of that, it becomes, if you are deploying this, how do you, what platform would you work on? If you are going to use your own laptop, I don't know how long it will take you to deploy that kind of thing. If you are going to do that, to deploy it on the on your simple laptop, first is the development process. So some of the development process, because of the size of data, you need GPUs, high-powered GPUs to do that. So, and memories as well, because that huge data, they have to be running. And again, the processor core, how many processor cores do you have? So when you are dealing with these things, the complexities make it a little bit difficult. So one of the things that we do is, if it's a very light solution that you are developing, now we look at the size of the code that you have. And then we find out that because we give you a model, the model is like a function. Let's call it f of x. Y is equal to f of x. That is it. That's your model. Your model is f of x. And you are looking for an output of y. So that f of x, the argument you are putting it is x. So that function that has been written, you ask yourself, what is the size of that function that has been written? And that function that has been written, if you want to use it to produce some results, how much memory space would you need? So if you are looking at IoT-based solutions, then we look at it and say, look, if I'm going to put this on a chip, the chip that I'm going to put on, is it giga level type of chip? Or if you take your typical laptop, some of you have your laptops are operating at levels of 60 gig, 80 gig, 100 gig. If you take a typical IoT, you won't get 100 gig. So if your model can run on something that will take care of, let's say, about memory of, it needs a memory of about 40 gig, then you cannot run this on that type of device. So what you will do is, the TensorFlow has something called TinyML. So that TinyML allows us to be able to scale down our model to an appreciable size that we can then use it to deploy on it. Because if you are doing something on your laptop has more luxury of space, so you don't have a problem with it. If you are deploying something on your mobile phone as well may also have enough of space that you don't worry too much about. But if you are doing something for your devices, that is where the challenge is. Ken, if you are online, if you can also add up to it.
Yeah. So, one more question. I was asking, what would be the trade-off in the case of a TinyML and then the usual large ML? What would be the trade-off?
Oh, you mean the trade-off that as a result of you? Ken, please go ahead.
Okay, so please can you hear me now?
Yes, sir.
Okay, so just a little contribution to your question. So sometimes the trade-off is inherent, okay? And the example Dr. Prof. Mills was using about the kind of problem you are trying to solve. So for instance, if maybe you are working or you are building a system which you are going to deploy on maybe an IoT device, okay? The processing power of a typical IoT device is not as capable as you would have with a normal computer. So the issue about maybe predicting rainfall, maybe you have a sensor that has maybe a little bit of a microprocessor attached to it that is able to process the data, maybe get some weather information and maybe do a prediction instantaneously. Because of the resource constraint, you'd want to have that kind of a tiny ML deployed on it, as against maybe if you are working on bigger projects, maybe you are processing images and stuff like that, you definitely need a bigger model to work on a bigger machine. I don't know if this brings some understanding to what you are asking.
Yes, sir. Yes, sir, it does.
All right, thank you very much.
Okay, so I'm coming to show something. So can we see what I'm sharing here now? Have you seen this? Please, have you seen what I'm sharing?
Yes, sir.
Yes, sir, we can see.
What I've highlighted, can you read it?
Says teachable machine learning.
Aha. So let's
with
copy
Google.
this. Let's do this I'll put it on in a chat. You can then okay. You don't need okay. So you don't need the bullet there. What do you call it? The dot there. You don't need it. So copy this and then paste it into your web browser. And then it will open something for you. What it will open for you, you can now, there are some fun there that we want to play some fun. Let me see if I can. So this is something from Google. So it helps us to do what we call some basic solution. We can do some quick something on that. It has, when you go scroll down, let me see how to use it. Okay. So you click on get started. This one we just try. When you get a chance, you can later on try it. So click on get started. Let me see if I can share that one. Okay. Okay, so you can see that when you click on get started, then it will open. Please, are we there?
Yes, Prof.
Okay, so if you already have a new project, if you have an existing project, fine. If not, if you have a new, you can, if you have an existing project, you can open the existing project, or some file that you want to use. This allows you to do some training. What it has for now, they have three things. We can do image, we can classify image information. We can also do audio, and we can also do post. So click on the image. When you click on the image, it tells you something. So whatever you want to have, a standard image or embedded image. So let's click on the standard image. When you click on the standard image, now we have two things. The top one is class 1, and the top 2 is class 2. So this is something that we normally do as fun game with students. So you can decide to take yourself. The moment you say, if you select webcam, the camera on your laptop will start working. So when you click on that, your camera on your laptop will quickly come on. So now I'm going to I will now create a number of data points for my face image. So we normally use it. We have used this one for fruit, mango. We use it for mango, orange, and then pear in the Huawei lab. We bought it from the computer science area, and then we did the experiment with it. We bought banana with orange. Now, so we did various combinations. So you can use it to create your own data. So if you are done with that, then it will now ask you, you now need to take the image. So you see that it creates a spot for you where you can take your image. If you have seen your image, there is something there under your image called hold and record. So you press, you hold on it, you see that you have as many images that will be recorded as you wish. What I press on, I've generated 37 image samples of myself. So that is my image. I want to now do a second image. So that second image, I will use, so that is my class 1, my category 1. So I'm trying to compare two things, to sort two people. One is me, other one is called calculator. So I'm in class 1. We can use it for gender, male and female. We can use it for anything that has to do with what we call binary categories, either yes or no, black or white. So once I finish taking my images, then that is for me. Then I go to class 2, and the class 2, I'm going to use my calculator. Then I take as many images as I can for the calculator. Once I'm done with that, it means that if you look at, see that as you are doing it, it is giving you the two data sets. They are all connected to something called model training. Please, have you seen that?
Yes, please.
Yeah. So it means that the algorithm, I'm going to pass these two data sets now to the algorithm. That is what you say model training. And so I can now click on the train. I say train the data for me. When I say train the data, you see that it's going through pre-training data evaluation. So data cleaning and all those things, the pipeline is going to go through all those processes. Okay, unresponsive wait, okay. So you see that now it started with the training. So 0 up to 50 is now training. So it depends on how much you have. So when you get the time, you can play around with this. So these are, you see that is training. It has finished training. It's set up to 50. So it means it has finished training now. So now that it has finished training, you see that on my left, I don't know whether you are seeing it, but it has, I can export the model. I can export the model. Now, the model has been trained. So you see that now, I'm now going to test the model. And in the testing phase, whatever object I put there, see that you have an output. Output is class 1, class 2. Once I put my face there, it means that I've provided my face sample into that function, that is the algorithm, and it's going to predict whether I belong to class 1 or class 2. So when I put my face there, it said 100% detected in class 1. If I put something also there, it will also be able to tell me whether it is whatever object it is. So you can use this now. Let me see. When I put a calculator there, it has detected it correctly. It said 100%. It's in class 2 category. So what I'm trying to do is I generated two groups of data, and I apply it to my algorithm, and the algorithm trained the data. So that data training process, it divided the data into two categories, one for training, one for testing. After it has trained and tested it, then it's now going to tell me now, after training and testing, it means that the model has been trained. So it's now there, what is the next? If I were to deploy it, then I will deploy. Then I can now apply my face image to it. If I apply the face image of Jonathan to it, it will be able to go through, and it will go through the compare image information with the information that has been trained and see whether Jonathan indeed belongs to class 1, that is me, or is a calculator. So now I want to show you something. Under the train, you see that there's a drop menu there called advanced. Please, have you seen that?
Yes, please.
There's a drop menu called advanced. On the advanced, there are a number of things there. These are things that we'll be dealing with when we come to the actual model training. It has what we call epoch. So the epoch, it is the number of iterations that it goes through in training the data. And we have what we call batch size. The batch size means that the number of batches, how many samples the batch it does at a time. And it has what we call learning rate, the rate at which the model is learning from the data. All these are things that we'll be dealing with when we get into the details as we go along. Now, so that is about that for that. And then the last segment I will touch on is I can export the model. So when you click on the export, you see that under the export, it will now give you the JavaScript. So this is where if you were to now implement this on a mobile app or web app, this is where normally JavaScript then comes in. So it converts it into the TensorFlow.js. So if you are developing it into any of the application platform that you are interested in. Now, if you are, on the other hand, you are interested in maybe IoT-based solution, we have something called TensorFlow Lite. When you go to the TensorFlow Lite, it also now help you to develop those things. So you see that when you go to the TensorFlow Lite, the number of instructions under that one is very, very minimal. Please, have you seen those ones?
Yes.
Yeah. So on that, you see that it has what you call floating point, quantized, and then HTPU, on and on and on. So you can download your model onto that. Once you are happy with, but this one is just a dummy sum. This is a simple, it's not complicated. It's very, very simple. So you can play around with these things if you want to just see how these things work out. So that is how these things work. But what we are going to go through with you, we are going to do full-blown solution. And we are going to use data sources from, we will show you where we can get open data sources. The Kaggle, the MIT, and all those, PhysioNet for MIT, and the PhysioNet for more of the health solutions, and the Kaggle also for any type of solution that is also available there. So when we get to the data, we'll show you all those. When we come to the data side, we'll show you all those things. And we'll pick in data by data. We will look at every time we are going to do an example, we'll choose a different data set to do the development with you. So that is about that for the process. My time is up. It's 6:11. So I think I will end here. If anybody has any question, then you can please ask. If not, then we close. When we meet on Friday, then we'll continue to finish with the session 1. We will now talk about the algorithms, the way they are, how they work, and then the various types of algorithms under each of them. And then we will now touch on the neural network, the basic architecture, the human brain, how it is modeled in terms of the algorithm that we work. And then we'll move on to the next week will be for session 2. So we have to finish session 1 before we go to session 2. We will put the material, is being recorded, so we'll put it on the platform for you. And what we normally do is we have a GitHub that Ken has created. So we were using it, it's his GitHub, but we were using it for the first generation, we were using it. So we'll also share the GitHub link with you. That's where we'll put in all the codes we'll be writing with you on the examples that will be working with you along the lines. We'll put it there, and then you can pick it also. Because every session will give you some trial case to try your hands on. Okay, so we close. Ken, do you have any concluding remarks to share? If not, then we close.
No, sir, I don't have any concluding remarks.
Okay. All right, then. So we see ourselves on Friday at Yeah, the industry people, what they said was, 4 o'clock will be next week. They will come on. So they said 4 o'clock will be a little bit tight for them. So they would want to start from 5 to 7. So next week, the industry group, I'll communicate with you. They will start from 5 to 7 because they have to close their work and then they will come online. Okay, goodbye to everybody.